and I'm reading his biodata, the various softwares which are mentioned. I'm sorry, Bhaskar, I'm not aware of all these. And it's like all new tech, new age, new area, new era software tools that you are very professional of it and very expert of it. So the technology stack which Bhaskar possesses PHP, Mean, and Mer, and then cloud platforms on which he has worked and has expertise are AWS, GCP, and Azure. Architecture, MVP architecture, and the SaaS architecture on cloud is expert on it. Various development processes, Scrum, Kanban, DevOps tools, various build servers and monitoring and containerization. He has experience of almost a decade of experience, decade years of experience, and he's a technological guy. Technology guy. He used to like sitting alone and then working on and bringing his whatever his brain on machine and make it happen. Quality is designing sustainable architecture is his passion. He worked in many companies at a very high level, and is now currently working in Escape. He has developed many projects in which this type of handling of big data is there. So I request Bhaskar to elaborate how such big data can be handled and what are the different techniques and tools which are used in market and in the industry to cope up with this type of big data, and then how analytics is done in the industry. So thank you, Bhaskar, for joining us and sharing your views, sharing your expertise. You can share your presentation and start your presentation. Thank you very much.
Thank you. Thank you, sir, and very good afternoon to all of you. So I can see plenty of people joining in. So very good afternoon, and I hope I am very loud and clear, audible to everyone. So there are a couple of things which I would like to share before we start for the session. So first of all, thank you sir giving me this opportunity to go ahead and to share very little of what I know about. And second request I would make to all of the participants. So guys you can treat this as more as a discussion. So I would expect and request at the same time if you all can unmute and take part of the discussion, so that would be very fruitful, and that's how I feel you can take away most out of the session. So please feel free to ask as many questions as you want. So I would be I will try at my best to answer them. There might be a cases if I fail to answer something right away, then probably I will take that question, I will do something some kind of research on something which I may need to do, and then I will share the answer, appropriate answer, or to satisfy your query. So but that doesn't mean that you should hold back from asking the question. So please go on and please keep it interactive. So yeah, so let's start with the session then. So I will put my video off now. So I'm not that photogenic as you seem. Cool. So first of all, let's start with the discussion, guys. Instead of talking about what is everything and what all this industry is doing and everything, let's start with the very basic stuff. What do you think? What is big data? What is your understanding? What do you visualize as a big data? What is big data for you? If I have to ask you.
Huge data.
Huge data. Okay. Very good. Thank you. Anyone else? You can unmute, guys. I mean, you can unmute yourself and you can talk. Okay, so big data is silent, is it? So cool. So someone has shared it big data is some kind of huge data. May I ask the follow-up question on the same? What do you mean by huge data? Can you define a huge data?
More data.
Sorry?
More data.
More data, you say. But how do we define a big data? Let's say 1 GB of data is big data, 10 GB of data is big data. What is your perception of it? All right. In that case, understand, guys. I mean, if I have to start explaining like big data, I will try to give you a fair idea, and that I will try to cover as many topics as I can at a very high level, so that at least I will try to establish a foundational line which you can follow later on for your further graduations. But what is a big data? So big data, I mean, is it a problem or a solution? So big data is not a solution. Big data is a problem statement. Okay, so I'm just sharing my screen. So please do let me know if you can see it. Let's say this system has been architected, very simple system. I'm just explaining one simple system to you. Generally, two-tier architecture. You might have very popular and very general, which we used to see. So this kind of application looks like something like this. Let me take you through the application journey. So let's say this is your application server where you are hosting your applications. Okay, and probably you have some kind of database in place. Right? It can be any kind of database you can think about, columnar or even row level or NoSQL, any kind of data you can visualize. This is generally how a simple, very simple monolith system looks alike, right? And all the users are sending request to all these people. I mean, to all these people are sending requests to these application servers. Okay. Now understand two things over here. First of all, when we talk about infrastructure, this is a kind of server. It might be virtual machine. It can be kept on premises. It can be even kept on any kind of cloud, or it can be even complex thing a combination of hybrid cloud up to extended up to serverless, which is still okay. But at the end of the day, the basic functionality of this layer is getting the request and serving you the response. A very basic responsibility this application layer has. Now let's make this application, let's name this application as on this Amazon.com. I believe every one of you is aware about Amazon.com and how huge it is. So if I have to tell how much huge this Amazon.com is, as per Gartner's report, I mean, I hope you also know Gartner. As per Gartner's report, which got published in 2016, if you take first 14 cloud provider except Amazon, first 14 cloud provider, so which may include Google, Oracle, Microsoft, IBM, Red Hat, DigitalOcean, all these 14 cloud providers, top 14. You can imagine how much infrastructure they have, individual of them, right? And if you sum up the complete infrastructure of all these 14 cloud provider, can you imagine how humongous that infrastructure would be? And if you multiply that infrastructure by 10, even that much of infrastructure wouldn't be even half, even 50% of Amazon.com. That's huge layer we are talking about. Okay, just this Amazon.com, only one application is using this much of infrastructure. Now that is just a fact, fun fact wanted to share. Now second thing, understand, whenever we are talking about any kind of infrastructure, that every infrastructure is capable enough to serve certain number of people, right? Let's say for minimalistic scenario, this infrastructure is of having let's say 2 GB RAM. Okay, it can serve almost, let's say, 10 concurrent users at a time, right? What will happen if your users or if your user base increases more than 10 concurrent users at a time? What will happen? Anyone? Anyone, guys?
Conjugation.
What will happen?
Conjugation.
Pardon, I am not able to hear you clearly. Can you please come again one more time, please?
Conjugation.
Congestion. Okay, you mean to say congestion. So basically, that congestion will result into probably either you will not get even responses from the server, right? Or even it may even stalled, or even it may go down. Okay, so these kind of resulting that condition would result into. However, how you can control? We can beef this. We can beef this off. We can increase the capacity of this application server, right? And that's how you will be able to cater to more number of users. Probably if you increase, let's say instead of 2, if you increase 4 GB of RAM, then probably you will be able to get this kind of performance, 20 concurrent user at the same time, right? That's how you can probably get rid of. This is one of the way. Okay. Now, don't you think by the similar way, your database where you are storing your persistent data, that will also be having some kind of infrastructure at the end, isn't it? It must be having some kind of so I will leave this apart now, and I will just focus upon your database. Now, whenever you are having
Sir, your voice is not clear, sir.
Am I not clearly audible?
Now it is audible.
Okay. Thank you. So when we are talking about this database, okay, so don't you think this database will also be having some kind of infrastructure, right? Correct. It must be having some kind of RAM. It must be having some kind of storage, right? And depending upon how much that capacity of that infrastructure you may have provisioned, right? It will also be able to cater certain number of users at the same time. Yes or no? When I'm saying certain number of users, you can even visualize those certain number of users as an number of queries you can fire on that particular database, right? So let's say this is also having 2 GB RAM. So as a safe assumption, it can handle, let's say, these many requests at a time, correct? And as long as you keep your storage increasing, right? Don't you think your performance will be hampered, right? Guys, can you please respond? Yes, no, anything?
Yes, yes.
Yep.
Yes.
Thank you. So you're your performance would be for sure impacted. Now your performance is getting impacted because of two things, if you practically understand when it comes to database. Very first thing is, obviously, very first thing is the infrastructure you are you are trying to configure, right? Infrastructure you are trying to configure. So one way is, obviously you always need to add or beef up your infrastructure. You need to scale up your infrastructure in proportion with the storage you have. Probably 2 GB of RAM would be sufficient enough to crawl 20 GB of data when we are talking about a sustainable performance, right? 2 GB of RAM probably is sufficient enough for 20 GB of data to crawl or to query 20 GB of data. What will happen if your storage increases up to 200 GB? Your performance will be for sure impacted, right? If it's get impacted, that's what we say a problem of big data. In a simple layman language, what is a big data? Any number of any number of data, depending upon your architecture and your infrastructure capacity of your application, of your product, it can handle some certain amount of data flawlessly, sustainably. If your data increases beyond that, then you will start facing the problem of big data. Means that amount of data probably is huge in size for the system. Need not to be necessary that has to be really huge at its as we understand it. So probably for this kind of system, for this kind of monolithic system, probably 200 gigabytes of data is a huge data to process, and that's why your performance is getting impacted. Yes or no? Right? So this is what we say big data, and that's why this big data problem arises in any kind of product or project. Now, if this has understood to everyone, I mean, if everyone understood this, that big data is a problem, is not a solution. Okay. Now, how can we handle this problem? So there are two ways to handle this problem. So first way is, it is again debatable. So the first way is you increase the capacity. You increase the capacity of your infrastructure in proportion with your storage or your data. Okay. Probably your problem will be resolved for now, only. But obviously you are just like, that big data problem, you are just delaying it. Tomorrow, if your size of data increases beyond even this limit, obviously you will again face that. You will again encounter the same scenario, right? So this is exactly why some certain tools and technologies, like, people have like, research, and people have like, came up with some certain tools and technologies, right, to handle some kind of specific problems along with the big data. That again, depending upon what kind of use cases we are talking about. Okay, so let me give you example. Everyone is aware about LinkedIn, pretty much.
Bhaskar, it's like a very different perspective altogether that generally I have ever seen. So I really appreciate it. It's like a very good perspective of big data, because we already always generally have a different perspective from the other point of view side. But it's like a good structure, good thing.
Yeah, thank you, sir. So, guys, everyone is aware about LinkedIn? Pretty
Yes,
much?
yes, yes,
Perfect.
yes.
Yes,
So
yes.
basically, if you have already seen, like, let me show you, like, just don't focus on my LinkedIn credential, please. So most of the time, like, you used to see this kind of, like, notifications, right? These kind of notifications, right? All these things,
Yes,
right?
yes.
So obviously, I mean, how this feature is exactly working. If you practically try to understand how this feature is exactly working, this feature is working like, whatever my network is, right? Whatever my network is, how many people I do have in my network, if those people are doing some activity, so obviously everyone, I mean, just like me, I'm getting notified that your connection did this, correct? Right? If you practically now try to understand, if you practically try to understand, my network consists of like, thousands of people, right? Thousands of people on a daily basis. Probably they are doing like, averagely one user, one user is performing 10 actions. It can be like, commenting on someone's post. It can be looking up to like, someone's like, profile. It can be like, pushing some likes, right? Or endorsement to someone. So any person can do anything on LinkedIn. If my network is having 1,000 users, in my network I'm having 1,000 users, then if they perform 10 actions every day, so what we're talking about, 10,000 notification has to be like, sent out, isn't it? Yes or no, in this simple scenario?
Yes.
Correct. Now if we generally talk about this scenario, how many think as a LinkedIn, consider, assume LinkedIn is your product, how sustainably you can like, do this on LinkedIn. There might be probably billion users we are talking about, correct? Every day billion users are like, logging in, and billion users are taking hundreds of actions, so probably trillions of like, records are getting generated. Yes or no? Correct.
Yes.
And you have
Yes.
one dedicated database just to store these kind of actions that ABC person has looked up into profile. This is one record. ABC person, like, PQR person, like, posted a comment on your post. All right, this is another record. Just like this, trillions of like, records are getting generated every day within a LinkedIn. That too, resulting into like, one simple action, correct? And now you need to analyze. You need to analyze who was this user, how many people are there in his network. Every one of them has to be notified. Yes or no? Correct. So now if we are talking about storing this kind of data into database or anywhere you want to store or anywhere you want to store, tell me guys, how much compute capacity you will need to process trillions of data? Very basic scenario. How much time you think like, you will need, how much compute capacity you will need, like, to go ahead and like, to consume or process this much of data? Any idea?
Very high.
Sorry,
It
you
must
said
be
very
very
high.
high.
Correct.
Yes, sir.
It must be very high. We are talking about only day one, right? On day two, these trillions of data, like, gonna be multiplied again, correct? on day
Right.
3, on day 4, on day 5, after a month, after 6 months, after an year? Do you really think the cost you will be investing every day? There are certain follow-up questions now. Do you really think this scenario is even feasible, that we go ahead and be increase the whole capacity of LinkedIn every day? Is it really feasible?
That won't be possible. No,
Practically
that
not be
won't be
possible.
feasible.
Correct. So when
Hmm.
it comes to these
Right.
kind of enterprise applications, when it comes to these kind of enterprise applications, generally we do not go ahead and we do not scale up our infrastructure so drastically. Rather, what we do, we try to find some kind of way to process this data at a sustainable speed. I am saying at a sustainable speed. I'm not saying in real time. I'm not saying in a fast way. I'm not saying anything else. I'm purposely using this relative terminology, which is sustainable. So this data has to be sustainably processed, right? Practically speaking, if you even see LinkedIn, do you really think this notification which has came to me just now, when this action has happened? Can you see here? A day before, right? See this, correct? Day before, right? Can you see this, guys? That's kind of thing So here, depending upon the feature and the problem statement, I'm trying to propose a way over here. What I'm trying to propose is, do you think probably you have some kind of credit notification in your banking account? You have some kind of debit notification or credit notification. Do you really think that notification can wait up to a day or 2 days in real life? No, these kind of
No.
notifications cannot wait. Those has to be processed almost at near time, real time, correct? Whereas we are talking about LinkedIn notification. Do you think it can be uh, processed? It has to be, or it must be processed at real time?
Yes, yes.
No.
Yes,
This
we
kind of,
want it at real time.
okay. It's not about what we want. It's about what kind of data. Every data has some kind of attributes, right? Every data is having some kind of attributes. When we talk about financial data, yes, it has to be real time. When we are talking about let's say LinkedIn's case, probably this is something okay, we will be okay from a business
Can-
perspective. We will be okay to have certain kind of delay, right? Look at this, right?
Yes.
10 minutes, 10 minutes only, right? Kind of thing. That's what we are talking about, right? So now what I'm talking about, there is one specific attribute of a data. Okay, there are in kind of in terms of big data definition. So there is an there are 5 attributes, 5 V's of data. Okay, 5 V's of data. Those 5 V's are volume, veracity, variety, right? All those 5 V's are there. But along with that, there is one quality attribute associated with the data when it comes to processing it or analyzing it or basically consuming it in any way. And that particular thing is consistency. Consistency. And consistency can be further divided into 2 things. There are 2 types of consistencies. First is strong consistency, and probably second is eventual consistency. Okay, so when we talk about this strong consistency, so we are referring to immediate actions, real real time processing or real time consumption of the data. Okay, real time consumption of the data. And when we talk about eventual consistency, we are generally referring to we will be okay if that data is not processed or consumed at the real time. Okay, that's kind of thing we are talking about. So this is very important attribute of any data, and that basically plays very important role to decide a strategy upon what you will use to process the data, how you will use it, when, and everything else. Okay, so this is very important attribute, so please keep in mind that that helps us to decide how, on which way we want to go. Okay, now If this is understood to everyone, so that's totally fine. Any questions till now? Everyone understood this use case, basically?
Yes, sir. Yes, sir. Clear.
Perfect. So please don't call me sorry. Like, you can call me like, Bhaskar. So that's totally okay. So like, we can, and everyone also understood this scenario that processing this amount of data using any kind of rational or traditional databases practically is not possible, right? Everyone understood that this part also?
Right.
Okay. Thanks. Now, further. So what has happened? LinkedIn, I'm talking about in almost like, early 2000. So what LinkedIn did, their use case was they wanted to like, analyze the data, this data. And what this data is consisting of? This data is consisting of who did what. ABC user like, clicked on your profile or looked up your profile. This kind of like, data this is having. And LinkedIn wanted to process this data effectively and send out a notification to respective users that, hey, Bhaskar, like, in your network, someone, this person did this, or someone like, looked up your profile, someone posted on your comment, anything, right? So they wanted like, to send out a notification. This was the use case. So what LinkedIn did, LinkedIn like, started working like, on this, and they have developed one small utility internally in-house. Within LinkedIn, they have like, developed their own utility, and that like, they used that utility initially to go ahead and process the data and send out a notification to respective users. Basically, these notifications I'm referring to, these notifications, they developed in-house utility. Okay. And later on, they made it completely open source. Okay, they made it completely open source. They donated that particular utility to Apache Foundation. Okay, and that utility name is Kafka. Do you know? Have you heard this name? I hope you might have heard this name during this big data. Hello, everyone?
Yes, we
Yes,
heard.
sir.
We
Yes.
heard.
Okay, so that's how this utility
We have
like
heard
came
about.
to. Very good. So that's how this Kafka came to an existence. Okay. Now, just like LinkedIn, Facebook was also like, facing some kind of like another issue. Facebook was also like, facing some kind of another issue with their like, processing of data. So they developed their own model. They developed their own like, utility to process that data. Okay. And they named it Scala. And they also donated it like, later on to like, Apache Foundation. That's how another big data utility like, came to an existence. Okay, so what I'm trying to say, these utilities are not like, something which came out of the box. So try to understand this fact that every utility, whoever has developed, like, various organizations has developed, every utility they developed by keeping some kind of purpose in mind, some kind of their problem, like, to resolve that problem, they came up with this kind of utilities, and looking at the potential of that solution, they made it open source. And now all these tools and like, technologies are part of big data family, and that's what we say, big data technologies. Everyone understood? And what are the purposes of every, and everyone also understood that, like, that every utility or every tool we talk about in big data has some specific purpose, like, or some specific problem to target, right? I hope this is also like, clear to everyone, right? Now, if this is clear, very good. If not, then please you can ask me questions if there are some questions till this point in time.
Everything
Okay.
is clear.
Perfect. Thank you. So now, looking at all these like, tools and techniques, so obviously there is one further like, I will go further ahead and I will like, just shed some light on this. When they like, understand one thing. When LinkedIn developed Kafka, when Facebook like, developed Scala, or someone else like, has developed some other tool, like, probably Apache Pig, Apache Zookeeper, even Hadoop, even like, like, MapReduce, right? Goozy, anything, right? Even Hive, any technology or any tool we are referring to, understand what was the initial fact to develop them? Their initial fact was we have some problem and we need to resolve it for ourselves. That was the initial goal. Okay. They never kept in mind, or it was never ever an intention that okay, later on we need to open source it and we need to donate it to Apache Foundation and then everyone, the whole world will be using that. No, that was not the case. The goal was pretty simple. We are developing some problem. We are working on some problem, and we need to resolve that problem. That's why we have created this utility. That was the solely that was the sole goal those utilities had, right? What that is resulted into, obviously, if you are using some they have, as they have designed it as per their need, every utility every utility having their own, having its own way of installation, way of configuration, way of using it, right? There is no common thing. You it's very hard to find common convention while doing all these things. Just like generally we used to find a common thought process when we are learning new languages, right? If you're learning C, then CPP or even Java or anything else, what we generally do, if you understand C, then obviously we look up the differences in the syntax itself, because the same thought process is also there, right? When it comes to programming languages, so it is very easy for us to find some kind of pattern, right, in according to learning something new when it comes to programming languages, and that's why it is very easy also. But that's not the case with all these things, right? Because everything has their own way, their own thought process in mind, so that that makes it a little you can say a little confusing for newbies. But also it is very difficult some certain time if you want to configure and create an sustainable ecosystem using all these tools. I'm referring to if you want to go ahead and if you want to install all these tools to resolve your problem, obviously you will have to do a hell a hell lot of configuration and all those things. Okay, but that was the case with the on premises. When I'm saying on premises, it can be an infrastructure which is kept on premises. But to override, to get rid of this exact problem, that's why cloud came into picture. Okay, so I'm just moving ahead and I'm just blending it to some other flavor now. What cloud did? When I'm saying cloud, you can consider any cloud. You can even consider AWS from Amazon, Azure from Microsoft, or even OCI from Oracle, or GCP from Google, any cloud. What they did is they are providing many services. Okay, they are providing many services. Okay, and one of the category where cloud is very effective is providing and consuming big data services. How? So basically what they did, they came up with an equivalent implementation of these big data technologies in a managed way. When I'm saying managed way, what does it mean? It means that you don't need to be worried about how you will set it up, right? How you will maintain that, how you will make sure that it is always up and running. No, all that maintenance part and everything is managed by now that respective cloud provider. It might be GCP, Azure, or even AWS. Okay, and these managed services, I will be showing you an AWS thing, so I'm referring the terminologies which AWS as a cloud using it. So Kafka, they came up with one managed service, which is Kinesis, right? Scala, or even MR, which is this is something we used to say MapReduce. So for MapReduce, they came up with another service which is Elastic MapReduce in AWS. Okay, Scala and all those Jupyter notebooks and everything they came up with another managed implementation which is Spectrum. Okay. Just like this, if you want to use any kind of ETL tool, right? So all those ETL tools, they have came up with with another managed service, which is Glue, right? So another popular database, Presto. Okay, they came up with something as an Athena. So all these managed services becomes very makes it very easy to consume all these tools at at the lightning speed and set up your own ecosystem. Okay, so that's a very basic about all these services about we are talking. Okay, so obviously these names which I'm mentioning, Kinesis, Glue, EMR, Spectrum, these are these are from AWS. Okay, obviously if you go to Azure, so Azure will be having their equivalent implementation will still be the same, but they are using their own terminologies, right? Google, obviously if you want, if you go to GCP, then they will be using their own terminologies, right? But this is the crux. Everyone understood this? So how this big data is spreaded across and everything?
Yes.
Perfect. Now let's move on. If we talk about all these things, so let's basically take a very simple scenario. So where exactly big data is applicable, in the real life, in the industry, everyone right now even talking about data science, ML, AI, even freshers are talking about that, which is quite, I find it quite contradictory. So let me be let me shed some light on that too first. Assume one thing, guys. Let me take one scenario. So let's go to this Amazon. Okay, if you click on any product, let's say any product you click upon, this one. Okay, what do you see over here? Customer reviews and everything, right? And probably you will also see. Let me choose another product. Yeah. So let's say I'm choosing this one laptop, and if you choose this product, can you see Amazon is also telling you, let's look at this very specific feature. Okay, one simple feature. Do you see? I mean, generally when you go to any product, specifically on Amazon, it shows you two specific things along with the product. Something like this. Other people also buy, when they bought this item, they also bought this item along with this one and this one. Correct? You know this feature? Have you ever noticed it?
Yes, sir.
Yeah. Just like that, it is also showing you another thing, that there are other products which are related, or which are falling in the same category, like this. Correct? These are almost falling in the same category. Correct? Right? Now, assume. So these two things we are these two feature. So which feature you want to talk about, guys? Please choose one. I just want to keep it simple. Which feature you want to talk about? This one or this one?
First one.
This one? Okay. So people bought. Pardon?
Product related second.
Okay, then it's a tie. I have two votes for two features. So anyone else which feature? You need to settle it down on anyone. Okay, let's start with this, and then probably if you haven't understood this one too, then let me know. We will talk about this too. So understand. First, very first thing, leave this approach of storing everything in the database. Okay. Now, because we are talking about Amazon, do you know how many orders Amazon process every day, or how many products, new products gets added every day to Amazon? Can you imagine? Any number?
No.
Amazon, per second, I mean, every second, I'm not talking about Amazon India, I'm talking about overall as an Amazon, it process in practical life, physically, it takes and process around 1.7 million orders per minute worldwide. Okay, so practically speaking, like, how this feature would have been like, working if you try to imagine, if you try to like, just think about it a little more. So obviously, understand the user behavior. That's what we say user persona in the industry. Okay, user persona in the industry. User persona, if you want to understand user persona is nothing but a different kinds of types of users. I'm not saying different number of users. I'm saying different types of users your product may have. So that every type we treat it as a user persona. So understand one thing. Every user, let's say if you understand your user behavior, every user who is coming to your site, obviously, what is user behavior in terms of Amazon.com? Let's say you want to buy AirPods or you want to buy speaker. How you will search for a product? How you will search for the product? How do you generally shop on Amazon.com? Anyone?
Either search in the search bar or go through the categories.
Go to the
section.
category. Correct. Whenever either you are searching or whenever you are going through that respective category. So basically what we are doing, you are narrowing down to that respective product, right? Correct. And once you find your product, it might be like, this exact product which you want to buy, or else it might be a related product, isn't it? I mean, I can easily like, look for headphones, correct? I can easily look for like, this is how you can go for headphones. You will see plenty of headphones over here. All types of headphones, right? You can click on whatever you think is an appropriate for you, or even like, let's say you want to just go ahead and like, look some more information about this product, correct? If you like it, perfectly fine. Else, what you will do? You will jump to different kind of headphone. Yes or no?
Yes.
Yes or no, guys? Correct?
Yes, sir.
So
Yes.
understand in the background what kind of data we are generating, what kind of data you're generating, right? And you can look up like, these products like, for 10, 15, 20 minutes or whatever time you take. But generally, like, when you're coming on Amazon.com or Amazon.in, basically within that particular session, you look for some kind of particular product, having knowingly or unknowingly having one goal in mind. I want to like, buy a headphone. That's what my session like, is all about. This current session is all about, right? So what kind of data it is getting like, it is generating? Understand this. When I'm looking, I mean literally Amazon even just for your information, Amazon even collects every click you make anywhere. And you will find, if you want to try this out, you will find like, try this out, go and look for like, certain kind of products for like, 3 or 4 times, and you will see in your Skype or wherever you go on internet, you will like, try to see similar ads and everywhere else too. Okay, that's how that's how Amazon uses every single click, okay, which you make on Amazon. So now coming back to the topic, how your data is getting generated in the session one. Let's say because I am logged into Amazon. I'm logged in now, right? I'm logged into Amazon. Amazon knows about me, correct? Okay. So you need to log in, obviously. So once you logged into Amazon, Amazon will like, know about you, right? And then it is something like, we'll get session. Okay. What data it is getting generated, right? I'm looking up boat and some product ID, probably boat one speaker. Okay. Next time I looked for, I mean, I didn't like it. So that's why like, probably I jumped like, over, let's say this. Okay. All right. Then in the same session, probably I look for another like, headphone, which is this logic one, right? So that's how like, for every user, for every damn user who is coming to Amazon, everything is like, getting maintained. If I have to talk about this very specific feature, correct? Guys, you're getting this? Probably session two, you may look up to JBL, right? And then you may look up to Boat One, correct? In session three, someone else looked up for like, session three, and probably like, logic, and probably like both one. Correct? Someone may have like looked up to this. Now when another user is coming, okay, session for let's say by tomorrow and day after tomorrow, wherever. So guys, do you really think like how many like think about the volume of this like or like look about the try to visualize the amount of data you are generating. Can you imagine how much amount of data you are generating in a day only? How many users would have been there on Amazon.com in one day? Probably millions, right?
Yes.
Correct? All those million people every day are generating this kind of data. I'm only talking about very specific, just click. I'm only talking about clicking on products and nothing else. This much amount of data Amazon is generating, right? Only for this. Now, tell me one thing, guys. How you can utilize this data? How you can utilize this data? Anyone?
For
We
marketing
can find the patterns.
patterns.
To find the pattern. That is one use case. What kind of pattern you want to find?
Which products users are interested in, which type of users are interested in which type of product.
Okay, so now you are coming up with two things, right? First, which type of users? Okay,
Right.
which type of users? And second, you're talking about which type of products, correct? Now tell me one thing. There are two kind of things like these two are different. How you think you will define which type of users? How you will identify which type of users?
Based upon their account profiles.
Okay, what profile consists of? What you are interested into more? I mean, what kind of like are they male or female? Are they like based out of like
Right.
specific geography? What kind of attribute you are like referring to?
We can use all of these attributes like about gender, about location, which people from which region are interested in which type of products.
All right. Let's say, um, let's for now let's keep it simple. Let's use one attribute. Correct? Let's use one simple attribute.
Okay.
Are they like male or female? Okay, which type of user? I'm using only one attribute over here, male or female. Okay. Now, what kind of products like how you do it? How do you define what kind of products it is? What is the attribute of the product you want to consider? Just like you have considered this as an attribute of a user. What kind of attribute you want to consider out of products? So obviously,
Based on
whenever go on, please.
based on categories.
Based on categories, correct? So let's say electronics or books or household items, right? That can be category. These can be categories of like your product. Yes or no?
Yes.
Right? Now, this is understand. This is my step one. For simplicity, let's name these steps. Okay, this is my step one. Okay. Now, in step two, what you would like to do? You would like probably would like to analyze this data. Okay. So when you say analyze this data, what exactly you want to do? How do you define that you are analyzing this data? Anything? Anything, guys? What do you mean you will analyze? I mean, skip the technical part.
Associate.
How?
Association.
Can you give me like some kind of example? Basically, I'm asking for steps.
Like
How you will like to how you would like to analyze this?
is there any correlation of the type of user and the type of product?
Okay, so if I have to put it in a very almost layman language, so probably you may be interested to talk about, okay, how many percentages of male users are interested in electronic products or books products or household products, correct? Probably a very simple analysis, a probability, right? Simple. So let's say I would simply write down find percent of users interested in product category. Yes or no? That's what you want to do? Hello, hello?
Yes.
Correct? Everyone else, guys, you are
Yes.
with us or lunch was way heavy for everyone? Rest of the people are with us?
Yes, sir.
Perfect. So now you have this. Find percent of users you found, let's say by applying some algorithm some mechanism, by X mechanism, you were able to consume this data and find some kind of percent of users those are interested in products, different product categories. Now third step, tell me one thing, how you would like to consume this data now, how you would like to consume this data. What you want to do with this data now, tell me. Hey guys, come on. I mean, you can.
We can use it for
Anyway.
marketing. We can use it for marketing. Like we have seen majority of the people are interested in electronics. We will show advertisements regarding electronic to
Very good.
vast majority of the people.
Perfect. Way impressive. Now tell me one thing. Will you be sending marketing flyers by yourself to all of the users everywhere? No. Right?
No.
Probably you may would like to use any third party utility or any third party vendor to send all of that information on behalf of you. Yes or no? That's what we say different mailers or SMS or even online ad campaigns and everything. Right? Correct?
Right.
But when it comes to feeding your data to all this system, how you will feed it? How you will feed it? How you will share this data? Over the email? For sure no. Right? In CSV? For sure no. Then how about developing some API and sharing it sharing this kind of data with these kind of all the vendors and all these things will be more effective. Correct? Right? So what I'm trying to tell you, the way you want to consume that particular type of data, the consumption pattern, the consumption mechanism will also be depending upon what you want to do and how you want to do it. Correct? So probably instead of sharing it with the traditional ways, you may would like to build data streams to share your data. Yes or no? Right? Or even I can use this data by another mechanism. Do you know how? If within my product, if this is my product, if any male user is logging in, so probably what kind of products I would like to show him on home page. I would like to show him the category which he's interested in. Yes or no? Correct?
Yes.
Right? If female user is logging in, what kind of product I will show him? I will show her probably household goods, because that's what my analysis says. Yes or no? Correct, everyone?
Yes.
So basically, to consume this data on the front end, probably I will need something else, right? Probably instead of data stream here, I will need probably different kind of APIs. Yes or no? Correct?
Yes, sir.
Perfect.
Yes, sir.
So do you understand what kind of analysis you want to do? Okay. Now you need to these all steps are very much tightly coupled, are very tightly coupled to the goal you are trying to achieve. Correct? So does it guarantee that this kind of big data ecosystem will work for every other product? Is it guaranteed? No, because I do have my different goal to achieve, right? Everyone is everyone is with me. You're understanding this?
Yes,
Clear?
yes.
Perfect. Now, when we talk about big data or even any kind of thing, so understand one more thing, guys. That important thing is this can be even a tedious process in some ways. This can be even a tedious process, or I would say, I won't say tedious, but yes, I would say time taking process. Reason. Now tell me one thing. Tomorrow you introduced another attribute in your type of user, which is geography, and now you want to also include geography. You want to also consider geography while doing this analysis. Don't you think you will have to make changes right from first step till last step? Everywhere you will have to change now. Yes or no?
Yes.
Correct. So this is also one of the reason, depending upon the attribute which you want to consider, that if you're changing something in your big data ecosystem, then probably it may result into a huge amount of work everywhere, that depending upon what kind of attribute you are using. But for sure you will have to change at multiple places. Everyone practically do understand this fact and why it happens. Everyone is clear?
Yes.
Perfect. So now these kind of things are here. Okay. Now, how we can practically go ahead and practically do all these things. Now, industry used to say previously, I'm talking about when I was student, people were talking about data warehouses. Okay, because by that time cloud and everything was not very adaptive, or I would say these technologies even were reserved for some kind of certain kind of group of people. Okay, why? You need to understand one thing. What do you think of the companies? I left my answer I left one topic behind, so let me answer that too before I proceed. Now tell me, what kind of companies you think will be there, those will be having this kind of maturity or this kind of data in place which can be analyzed. Obviously that product or that organization has to be there for a sustainable period. Yes or no? That's when you can do this kind of analysis, or you will have even this kind of data even to analyze. Yes or no? Correct? Hello, guys, you're with me,
Yes. Yes.
right?
Yes. Yes.
So once you have this kind of huge amount of data, that's where you will be able to go ahead and take care of or even think upon implementing some kind of big data. Okay, some kind of big data implementations. Okay, now these companies are initially these were very minimal in count, but now these are way have been improved, and almost every business, every enterprise business nowadays is having this kind of requirement. Okay, and then based upon this analysis, that's where later part of this big data, later part of this big data comes into picture. Okay, all right. So if I have to show it visually, so something like this, you can visualize the industry pattern. Okay, first you need to have your product. I'm going very high level. Okay, when I'm saying you need to have your product, so I'm referring to obviously a complete architecture, a complete working product. Once you have your sustainable data, okay, I'm not referring to database. I'm referring to this kind of analytical or raw data, right, which you are gathering or you are interested into gathering in, right? Then you can basically analyze that. Okay, you can analyze that, and then you can probably do some kind of find some kind of patterns and everything. That's where you can see ML. You can uh, You can even use this like an ML models to like bring out some kind of actionable items, right? Based on that. So that's where like your AI comes into picture, and you can like either present it or you can do something like with that data. So that's where like your data science sits into. Okay, but the basis of this everything is your big data, right? Then all other layers comes into picture. All right, at very high level. Okay, everyone understood this? And like have a now a clear picture of like where exactly big data fits in and what exactly we can do in real life along with the big data.
Yes.
Everyone has a very clear idea about. I'm asking like one more time. It is not only about, I purposely chose like real life example instead of having a huge amount of like student records in any kind of dumb database. That's why I chose like this real life example. Everyone understood? So when you're looking at any feature now, can you imagine? Can you think how it must like it must be happening like behind the curtains? Everyone?
Yes.
Okay, perfect. Okay, now that's where like that's what the use cases of big data in real life everywhere, almost everywhere. Okay, and that's in the product life cycle, in the evolution of the product. This is exactly where like big data sits in. Okay, now let's take a quick probably like 5 minutes break. Okay, I just need to get a glass of water, and let's be back by 12:40, and then we will like start. I will show you like one real example of like data lake and everything. Okay, I hope that is fine with everyone.
Yes.
Perfect. Cool. So let's be back, guys, like by 12:40. Just need 5 minutes off. So thank you. I'll be back by 12:40. You too can take a quick break.
140.
Yes, yes. Just 5 minute break. Everyone is back, guys? Back. So I hope everyone is also back. Okay, I will assume like everyone is back, and I'm still clearly audible to everyone. Cool. So let's get back to the real life example. Okay, so I do have downloaded from internet this kind of huge data. Okay, these are 100 records, but we can go as far as the data is concerned. All right. So these are almost 1 lakh records. It's opening up. It's huge in size, but it is having this kind of data. No, this is still 100. Yeah, this much amount of data we are referring to. Okay, so you can look at it. These many rows and everything we have. Okay, now assume guys, just like this is an Excel sheet. Okay, so there are different kinds of phases when we talk about processing a data. Okay, so I'm just trying to tell you step by step. So very first thing, as in the previous example which we saw on Amazon.com, it is also same kind of data which can be stored anywhere, right? So let's try to put this into a simplistic architecture. Let's say it will be very great guys if you can be part of discussion. Product, you have your product. Let's say I will simply also make it application, and you do have your database, normal traditional database where you are probably storing all your product information, user information and everything. Okay, and now you started collecting this kind of data. You started collecting this kind of data. Okay, now one thing we have already understood that this data cannot be processed with this kind of kind of relational or even NoSQL kind of database, just because it is having huge size. What we generally do in real life, we do implement you also understand now consistency, strong consistency and eventual consistency. So depending upon this, how exactly we want to process the data, do we want to process it runtime or do we want to process it in terms of batches, right? How we want to process it? Let's say if you want to process this data in batch kind of thing, in batch, then what needs to happen? What needs to happen, right? So basically what needs to happen is let's say based upon some certain trigger or some certain condition. When I'm saying condition, so I'm referring to after every 2 hours, after every 3 hours or 4 hours, or if your data size is has accumulate that the data which you have accumulated, it has grown up to 1 GB, then probably push this data outside of database to somewhere else. Do you understand this? Hello.
Yes.
Yeah. So based on this, if you want to make it real time, then what we will do? We will use some kind of mechanism. As soon as data is getting inserted into database, we will move this to some other place. When I'm saying other place, that other place is someone who can process this data. Okay. We'll come to this part. First, obviously, we will have to take the data from the sources. In this case, our sources, your database where you are storing your data. It can be any kind of source. It can be even API or third party file. Someone is giving you file or anything, right? By any mechanism you can accept the data. Okay. If I have to tell you specific examples, if you want to go ahead and if you want to take data from database on real time or even on batch fashion, you can use this service. AWS DMS, AWS Data Migration Services. It's one of the service. I'm I'm trying to introduce new services to you just for the so that you know what you can use if you want to. AWS data migration services. Okay, just like that also, like, we have BigQuery and everything in Google too. Okay, you will bring this data to some kind of storage. Okay, generally in real life, we do not use block or file storage to store huge amount of data. Okay, because this data can be huge. So we generally store this huge data on object storage. In case of AWS, that data would be like that object storage would be S3. Okay, in terms of Azure, that, like, object storage would be blob. The name of the service is blob, B-L-O-B, blob. Okay, so generally we, like, we bring that data on some kind of object storage. Okay, now there is another also, like, twist. So what is that? If you are having a huge amount of data, let's say, like, 1 GB or, like, 10 terabyte, 10 GB, or even, like, terabytes of data you want to, like, store, depending upon, like, volume of your data, depending upon volume of your data. If your data is, like, in MBs or something which you are accepting, you can use, like, even this kind of files like CSV file or, like, XLS file. You can use that. That's totally fine. But obviously CSV and XLS will not be able to, like, store, like, terabytes of data or gigabytes of data, right? So obviously in such cases there are special, like, file formats, like, which has been introduced. One of them is Apache Parquet. Okay, Apache Parquet. Okay, this is also, like, one of the file format which is generally getting utilized in big data like, ecosystems, because it can, like, help you. It is capable enough to, like, to store terabytes of data within itself and, like, help you to, like, process it. So this kind of, like, file system is also there. You can even, like, upload these files, or you can accept the data on any kind of object storage. Once you, like, accept that data, okay, so obviously, do you really think whatever, like, depending upon your data source, in this case our data source is one rational database, so definitely that incoming data that you have, that will be having some kind of, like, format, row and column, yes or no? It will be having, like, it will be having some certain format, right? Hello, correct? I'm asking.
Yes. Yes.
Right?
Yes.
If you have more than one, like, data sources, or your data source itself is NoSQL kind of database, do you really think incoming data will be always having some kind of format, some kind of fixed format, or even some kind of semi-structured format, or it will be always having structured format? Is it guaranteed? Not at all. Correct? It can always change. Correct? So this incoming data may be of structured, or probably semi-structured, or completely unstructured. Correct? Depending upon your data source. Yes or no? Correct?
Yes.
Right? If it is structured, then probably whatever analysis you want to do on this, whatever analysis you want to do on this, okay, that may be, like, maybe you can say, like, easier. But if it's kind of, like, some kind of complex analysis you want to do, then probably first thing you may need to go ahead and you may need to arrange your data itself in some kind of format so that it can be analyzed effectively, right? So that tamming of data, right, that structuring of data has to happen somewhere. Yes or no? Depending upon, like, what kind of data you are, like, accepting. Correct? This is exactly where crawlers helps you, or even, like, for simple mechanism, you can even say, like, crawlers are some kind of ETL, like, tools or ETL jobs which runs and which parse the data and, like, put them in some kind of, like, desired structure which you want. So that's where, like, these ETL tools and everything, like, falls in place, right? Now once you structured your data, if you want to, these are kind of, like, completely optional steps. Every step is, like, completely optional, or even, like, you can treat them as a mandatory even if you want to, depending upon what kind of goal you want to achieve. You're getting? For example, if your data is already in a structured format, then obviously probably you don't need, like, kind of crawlers. right? You can straight away move that to like, you can straight away use any kind of like an analytical tool, right? If it satisfies your needs, correct? I hope guys you're getting this.
Yes.
Yeah, thank you. So now, once you like, do that, obviously, what else you will have to do? We can like, now, basically we can use our ETL, like, again, ETL tools and everything. So first thing, ETL tool will like, help you to obviously like, establish like, some kind of structure within your data. And then ETL jobs can also help you to parse that data and probably like, write down or identify some kind of data out of it, right? Creating a metadata or analyzing your data, putting out like, knowledge out of that data, like, that kind of layer, like, your ETL job can help you with too. So now, like, your ETL job can consume that data and can create some kind of like, this analysis for you. Let's say this, depending upon your business logic. What business logic? This. How many like, these attributes, and you can find correlation or whatever you want to analyze. You can achieve this kind of like, goals by like, writing down some small algorithms in ETL, like, jobs, or even like, if you want to fire queries, then obviously like, you can fire the queries and everything, right? It can be anything you can write down in ETL job. Okay, so this is like, can be achieved using like, any kind of ETL jobs. Okay, now once you wrote down, that output has to be stored somewhere, correct? That processed data using ETL has to be stored somewhere. That's what we say data store. That's what we say data store. This data store is nothing but the processed data. Okay, processed data. And now if you want to consume that data, let's say on a dashboard, all right, dashboard, you can create dashboard. There are like, different services available, right? You want to like, share that data to someone else. Okay, you can create your streams, data streams. Okay, if you want, okay, that you want to like, share that data like, with someone else, let's say for um, marketing purpose, all right, then like, what you can do, you can like, build up your APIs, right? And as an additional layer on top of the data store, right? On top of this data store. So that's what like, guys, you can do with this. So basically, initially, people used to like, create. People used to create. I mean, understand how we are consuming the data right now. Okay. Initially, you might have heard about these three terminologies: data mart, data warehouse, and right now, market is like, settling down on data lake. Okay, so basically what is data mart? So you can say like, data mart is a small amount of data we can like, query, or we can fire analytical, like, some kind of analytical query, and we can bring out analytical facts. Okay, so what I'm referring to, you probably like, obviously you must have been like, aware about these terminologies: OLTP and OLAP, right? So all these three things are falling under OLAP kind of thing, online like, analytical processing. So data mart is like, a way we are doing it at a way smaller scale, but using SQLs only. Data warehouse is we are doing like, at a very huge level, but that is also like, in terms of SQLs only. Okay, when we talk about data lake, we are not anymore talking about only SQLs. We are talking about even like, having multiple steps. If you can see, every individual step like, can be established using like, any kind of different set of tools and technologies and utilities, where once your outcome is like, once you achieve your desired outcome, you can even further use that by any mechanism. It might be like, creating an business analytics dashboard to give like, an insight like how my business is performing or how my business is doing. Or you can even like, in real time, you can even like, stream that data, or you can even like, create APIs to feed it like, to the next level of like, process. Okay, so that is what we say a data lake. Okay, so for example, let's look at the data that we have. This data, like, this is the data I have: employee ID, name, like, what is the name prefix, first name or middle name, right? Last name, gender, email, and all like this HR data I got it. Okay, and the complete information about this. Okay, now I want to do something. Okay, and this data is something. Let's assume these are all Amazon users. Okay, these are all Amazon users and their password and their complete user persona I do have. Okay, now this data, where I can keep it, obviously I can go ahead and I can keep it in some kind of object storage. Okay, let's assume this data is coming out of your database. If you want it to come out of database, you need to use DMS, data management, data migration services. Okay, or even you can simply, for simplicity, even you can manually take a dump, SQL dump, and upload it to any kind of object storage. Okay, so I'm now going to use AWS. Okay, so this is AWS. This is my one simple S3 bucket as an object storage. S3 bucket. I'm uploading all this data over here. Let's say this one. I uploaded it, 26 MB of data. It's almost 1 lakh records we're talking about. Cool. It has been uploaded now. And if you see, I have uploaded my data is now on my object storage. Fine. Now what can I do? Okay, so as it is already structured, that's totally fine. I don't need any kind of crawler to go ahead and to do this. But what I want to do, I want to crawl all the data and gather all the facts within the ETL. So what I'm doing right now is I'm simply going ahead and I'm using one ETL tool, which is this AWS Glue. Okay, which is this AWS Glue. So how I'm doing this? So if you go to simple AWS Glue, all right, cool. First, you need to just create any kind of crawler or data discovery services. Okay, I don't need Glue Studio. Cool. So I will go ahead and I will create a simple table and simple crawler.
చూడండి నాకేం ప్రాబ్లం లేదు కానీ రాదు మా అందరూ ఒకవేళ అటెండెన్స్ చెక్ చేసుకోండి if there is any difficulty please let me know on the same day.
Can someone please go on a mute? So I can create some kind of crawlers.
ఇక్కడ సైడ్ కి ఎడిట్ అనే బటన్ రాదు. అదే ఈ రోజు అయింది అనుకోండి ఇక్కడ సైడ్ కి ఎడిట్ అనే బటన్ వస్తుంది. అదే అంటున్నా అందుకే ఏది ఆడి చెక్ చేసుకొని నాకు చెప్పండి నేను చేంజ్ చేయడానికి ప్రాబ్లం ఏం లేదు నాకు.
Sir, can you please put someone on mute? I cannot do it.
Yeah, wait, I'm checking it.
Yeah. So,
thanks.
Yeah, thank you. So guys, what I will be doing, I'm just creating my crawler and I will write down my simple all the business logic the way I want to crawl this data. So I'm just adding a crawler. Okay, so you can put a crawler name whatever crawler name you want. Okay, I'm saying I want a crawler as an sales information crawler. Fine. Next, and what is the data source? What is the data source for your crawler? Okay, so I'm saying my data source I would be defining data source. Data source means from where this crawler should take a data. Okay, I'm saying yes, I will be defining it. And whatever data, do you want to crawl all the files and folders within that data source, or only newly created, or only the changed one? What you want to crawl? I'm saying crawl everything. Next, and where you want to store the data? I mean, where you have stored that data, right? So on S3 as an object storage, or you have any kind of JDBC connection to any third party. Okay, you have any DynamoDB or DocumentDB, MongoDB, Delta Lake, where? So in our scenario, I kept our data on S3, and which basically which S3 bucket we have stored. So choose your S3 bucket. So our S3 bucket was this one, sample data lake records. right? So I'm saying my my data has been kept over here. So select that, perfectly fine. And next, if you also want, you can put this that okay, read only files those are falling under, or let's say even greater than 50 MB or whatever it is. Okay, you can even specify this if you want. Next, do you want any kind of other data source? I mean, do you want your crawler to read data apart from this one data source also? If yes, specify another data source, and you can add multiple data sources to one crawler. Okay, that's fine. I'm saying no, I don't have any other data source. Fine. How it should how it should crawl the data? This is kind of permissions only thing. Okay, so I'm using these permissions. Okay, or even I will choose existing one. Cool. Next, and how it should run now. Right? I told you. Do you want it to be on batch basis, on demand, or how you want to crawl this data? Hourly, you can set the frequency, hourly, or even monthly, weekly, whatever it is, or even custom. I can schedule it for on minutely basis. So every minute it will run. Okay, but I'm saying run it on demand. I just don't want to run it I just don't want to make it real time. So run it on demand. Perfectly fine. Next, where it should process, where it should keep that data. So basically, I'm now trying to create my data store. It will crawl the data. It will have my business logic, but where it should put all this data. So I'm saying put all the data into this data store. Okay, into this data store. All right. Say next. Review everything. Right, and simply say finish. Okay, finish. And your crawler would be created something like this. Something like this. Once you do that, just run the crawler. My crawler is now started running it. Okay, so till the time, can someone mute? Yes, get some background noise.
I am on mobile, so I'm trying to do her mute, but let me.
Bhaskar, please can you show again from where you have chosen the S3 bucket that I missed it.
Sahiti, are you there? Please mute yourself. Manoj,
Bhas-
Manisha, are you there?
Sure, sure. I will show it to you. Just a moment.
Yeah, Bhaskar, you can go ahead.
Sure. Perfect. So from where I I when I specified add crawler and everything. So just put down your crawler name. Okay. And from here you can specify your data source. And I have chosen S3 as my data store. I'm just putting down over here. From here I'm choosing my S3 bucket. Okay. So once your crawler is running, I mean, understand guys, this is this crawler will contain this is a very simple crawler which I have created. But if you want, you can put your business logic too. I mean, identify if there is these users are male or female, right? From which geography they belongs to. You can put that business logic too. Okay. But for simplicity, I just created some sample crawler. Now understand one thing: the crawler frequency. How we kept the crawler frequency? We kept it on demand, right? Means what? It won't run unless until we explicitly run it. Okay, it won't run till the time. But what will happen if you keep it on, let's say, hourly basis? What will happen? It will automatically run at every hour, correct? Yes or no? Guys, you're with me? Correct? It will automatically run on hourly basis, right? So this is the frequency, and when it will run, it will crawl the data according to your business logic which you have placed. Okay. Now it has created, it has updated all the data in this kind of data store. Okay, this is my data store, and you see that has been updated just now. Okay, now this is my data store which contains my process data. Now what can we do? We can use some kind of little intelligence. This process data, we can use some kind of intelligence to how to interpret this data. That's where another service comes in picture, which is Amazon Athena. Okay, so if you understand, Amazon Athena is capable enough to go ahead and to create all these things. So now a very basic thing, if you want to do some business analysis or prepare some kind of report, this is the layer, right? This is the layer where you do it. For example, where you want to query, I want to query on my this data store which we just created, and what is the database into this data store? Sample DB. Okay, and you see, just put it. You see, this kind of data it has this data store has processed one. Now, what you want to do this data? What you want to do with this data? Let's say I want to identify how many number of users are there and everything. Okay, so what I'm doing, records limit 10. I will remove this and I will say run. Cool. It ran and it took all these things. So I will create a view out of it. Okay, so I will create simple view from a query. I mean, what I'm trying to do, I'm trying to build some kind of real-time dashboard. How many male users have registered? How many female users have registered? Kind of thing. Analytics, simple analytics. Okay. So first is something I'm creating. Where let's identify gender or age. Where age in years is greater than 40. Okay, so these many users are here. I'm creating a view. So this is view name is, I'm saying create. Okay, so this is one of the view which we have created. Now I'm saying I'm creating another view, another analysis where I'm saying where gender equals to female, run. Expecting all and some. Okay, I will create another one. This is not a SQL. Okay, I mean it looks like a SQL, but it's not a SQL. It is Presto. It is Presto DB. Let's create something else. Weight in kgs have Weighting kgs, I would say greater than 70. Okay, so this view has been created. Need diet. Okay, so I have created two other views. Okay, two views. One is like adult users. Another is like the people who are in need of like dieting or exercise kind of thing. Okay, as per my logical just. Now I'm just trying to use another service which is Quicksite. Okay, Amazon Quicksite. So we just need to enable it. So just a moment, let it create. It is free. Amazon Athena. Okay. This data like so use Quicksite manage role. Okay, and I want this to give. This is a normal setup, so you can skip it. And I want Athena. Yeah. So basically, Amazon Quicksite is nothing but like and a service by using which you can create like real-time dashboards and everything, right? And you can present your data using like some ready-made widgets which are already there. Cool. So I would go ahead and if you want to do it manually, for sure you can do. Okay, or even like there are some sample analysis which you can look up, which you can look up into. But let's create our new analysis, and I'm creating my news like data set from where? From Athena, and my data sets known. Data store name is AWS data catalog. Cool. So it has been connected. Now this is sample TB, and what exactly we want? Do we want all the data, or do we want only like view, or what we want? Okay, that's what it is. So I'm saying either you can create that like analysis layer either in Athena, or even here also like you can use your custom SQL to specify what exactly you want out of that. Okay, so that is totally fine. So I'm using this AWS catalog schema. I'm using sample DB, and which table you want to use, either like adult, I mean that view, right, which contains like adult user. And now I can like create all other things, all other like parameters where I want to analyze that. Or I'm saying I need dietitians. All right, so what you want to do, name, prefix, whatever you want to do, you can like use it. Data set, say spice, or direct query, anyone you think. Select Count start from just a moment, guys. Good. Now data has been imported, and now if you want, you can put down you can use these widgets just to visualize your data now, your analysis. Okay, so now I'm location, state, country. Good. Okay, now you can use another widgets if you want. So first let me need that analysis and simply save as. I mean, you can keep adding all these things. Time value. Okay, I will need a special record for this. But I will this one. Cool. So okay, looking at the time, I'll just wrap it up on this. Cool. So guys, if you understand this, right? So what we did is we just had all these records, and now based on this raw records, right? We were able to analyze and put our data in this format. Can you say this? These many users I do have in my database or in your data store. Those people, based on we queried that how many people are are in need of exercise equipment or need diet, and this is what I got it. This is what we got it. So these many people basically need in these geographies. We need we have a potential basically, right, to go ahead and sell or even show these kind of ads. Which can consist dietary products or even exercise equipments or anything, right? So this is one simple use case, guys, which using this dashboard we can demonstrate. Or if you want, obviously you can even build another layer instead of using this Quicksite. You can even use Kinesis or API gateway to put or to build an API layer and share all this data with third-party system. Okay, this is one simple like dashboard, one simple use case like we have taken. Do you understand? I mean, everyone understood this or did not? Hello, hello. Am I audible?
Yes, yes.
Yeah. I mean, everyone understood this use case, guys?
Yes, sir.
I mean, this is one simple data lake we have just set it up, and now you don't need to refresh or do anything, right? I mean, you can keep it going, and as soon as your data, new data will be placed on S3, right? New data will be placed on S3. Your glue job or your ETL job will run, right? And automatically your dashboard or your data will be processed. You don't need to do anything. Okay. Hello, hello, guys. Do you understand? Everyone understood, guys? I hope everyone understood, right?
Yes, yes.
Perfect. So any any question, guys? Any questions you have on the applicability of basically these big data technologies and something? So basically, what we have used is we have used serverless versions of all these tools and everything. So this S3 is your object storage. Your Glue is nothing but your ETL job. Your Athena is nothing but your an analytical layer used in built in Presto, and your Quicksite is nothing but your presentation layer where you can say even something very similar to Grafana or even Datadog or even any kind of Kibana kind of tool. So these kind of visualization tools are available. So this is just a managed implementation of that. And this is completely, I mean, if you even practically understand, I didn't installed any Presto or I'm not even managing. So this is what it makes managed service, Athena. Okay, that's what the serverless model is. Okay, anyone has any queries, guys, on this? Any queries so far, or can I go ahead and explain you if you want to get it more, how can you do that? Hello, hello.
Yeah, if anyone has any query or comment, they can talk. All right, I think
Yeah.
you want to again explain something additional?
Yeah, sure. Just last thing I wanted to share, sir. So one thing, if you want, guys, you can go ahead and you can open up your AWS free tier. This is for your further graduation, or if you want to try something new. So here is the link, aws.amazon.com free, or you can simply Google it, AWS free tier, and get this link. Just look at it, and you can put up you can open up your free tier account over here so that you can take advantage of this free tier, which is almost available for 1 year free of cost, and you can try out these services, these big data services, without even getting into any kind of technicality. Okay, so that is one thing you have. And on other thing, if you want, you can have AWS training. This is another thing where you can find your all the videos are, if you want to learn more about these services on deep learning, on machine learning, just like that, even on architecting, or even on any kind of big data services. Okay, and that is something these are pre-recorded videos. If you want, you can go ahead and you can do that. Okay, this can be at least to start with, this will be useful. I think will be useful for you, at least to get rid of all these things. Okay. Yep, I guess
It's perfect.
yeah.
Yeah, it's like it's free services also that are available that we can try. And it's good that you have shown it, and that the case study was also very useful. Like it gives us an insight. Anyone want to comment on it, and anyone want to share their views on it? Okay, I thought Anchal want to talk.
Hello, no voice.
Yes, we can hear you. Okay, all right. So thank you, Bhaskar. On behalf of all the participants, let me thank you. It was a very fantastic session where you elaborated very nicely, as if you are working on in front of blackboard, and then you took that images, and then using those you showed the connection between various components of the so we could visualize the picture also, like how it happens. So thank you very much for such a elaborative session, and it will helpful to us to understand it in greater detail. Thanks a lot.
Thank you. Thank you, sir.
Thank you very much.
Thank you. I guess that's a wrap.
All right. So,
Yep. Thank you, sir.
you may
Yeah.
leave, Bhaskar. Yeah, you may leave.
Thank you.
So yeah, for the participants, we'll have a break, and then we will start at 3 o'clock, the next session and the last session of the FDP, where we will conduct a exam also, and all the details of the exam, our co-coordinator Manoj will tell in the next session. So we'll meet at 3 o'clock, and then we'll start our last session, and then, as I said, that you have you prepare your mind to talk at least for a minute. Most of you should speak so that we can get feedback also. All right. Thank you very much. We'll meet at 3 o'clock.